So, in this class we are going to learn about thermal expansion, that is the properties of matter, thermal property of matter. So, we have observed that all the matter expand when heated. So, this thermal expansion is not of a particular direction or dimension, all the dimensions of a body expand. So, all the dimensions of a body changes with temperature. This is what happens in thermal expansion. Now, there are different types of body which reacts differently with temperature. There are some expand more, some less. So, we can define some quantities, that is the coefficient of linear expansion, volume expansion and all such things. So, first let us see how the linear dimension of a body is affected by the rise in temperature. That is, we will call coefficient of linear expansion. So, we will denote this as alpha. Now, the expansion of a body is not simply along a line, it is a photographic magnification. So, when a body expands, so just like a photographic enlargement where all the dimensions proportionally increase, but we will study the individual dimensions separately. Let us see first coefficient of linear expansion. So, over a small temperature range, that is the rise of temperature is not very large. So, over a small temperature range, the change in length, the change in linear dimension of a body is found to be proportional to its initial length and the rise in temperature. So, let us denote this change in linear dimension as delta L. So, delta L is found to be proportional to its initial length L naught and delta theta, where theta is the rise in temperature. So, we can say delta L is equal to alpha L naught delta theta. So, we can have definition of L in terms of this: alpha is 1 by L naught, delta L by delta theta. Now, if alpha is the same at different temperatures, i.e. is constant, if alpha is constant, that it does not vary with the rise in change in temperature. So, we can, on integration, we will get this delta L is equal to L naught alpha delta theta. We will write this as dl, and then if I integrate, this is L1 L naught to L, this is theta from theta 1 to theta 2 or 0 to theta. Let us write 0 to theta. So, we will have L minus L naught is equal to L naught alpha theta. So, this L, final L becomes L naught 1 plus alpha theta. So, this is the length, new length, when we have increased the temperature to theta. So, if L naught is the length at 0 degree centigrade, then at theta degree centigrade the length will become L naught 1 plus alpha theta. This is the way in which the linear dimension of a body increases.